Good evening, friends. How are you all? I am so. So, we have seen the setting of relay with CT. All are current relay. One is instantaneous, one is IDMT, and one is restricted arcfault relay. In one numerical integrated relay, we are assembled all the settings. The rest settings are in HB stage 1 OCR set at 140% of full load, stage 2 OCR 160% of full load, and stage 3 OCR 180% of full load. So what we have done, you have taken the rated load current as 2 to 7.27, then 140% means 1.4, then it has been multiplied by 4 divided by 400, the CT ratio, and 1 upon CT ratio, because the current will reduce in the CT secondary, and then percentage over the full load current of relay is 5 ampere. So what is its percentage? So it is multiplied by 100 and divided by 5, it is coming around 79.54%. Set it in the OCR1, this percentage. Then stage 2 it is coming 90.9%, and stage 3 it is coming 102.2. Next, our traction transformer can take 150% overload current for 15 minutes and 200% for 5 minutes. So how to set it? You set it at 110% in the HV side, the rated current. Then again convert it in the CT secondary with the CT ratio and find out the percentage. It is coming on 62.49%. And in the LV side it is rated load current is 1111.1 ampere. Convert it in the CT secondary, that is 1500 by 5, and it is set to 100%. So 100% means 1, it is multiplied by 1, and then convert it in the percentage. Full load current is 5, and it's how much percent of this current is how much percent of this 5, that is 100 by 5, so it is 70.04%. So the same thing will follow in the LV side also, but the percentage of stage 1, stage 2, stage 3 is 10% reduced. Instead of 140%, it is 130%. Then stage 2 is 150%, and stage 3 is 170%. And the post overload also the same manner, it has taken 100%. 100%. Already you have shown it in the LV side, the post overload setting, and its timing also given. For the HV side it is 70-second set, and in the LV side it is 60-second set, and after 3 hours another overload it can withstand. Okay, so this is the setting for the current relay, like overcurrent and restricted arc fault. These are all the current relay. Then if you see in the feeder side, there will be current and voltage relay, and if you see in the transformer protection, for transformer protection we have taken so many mechanical relay also, like PRD, pressure relief device, then warning temperature, oil temperature. So I'll discuss in the next 2 slides. First I will discuss about the feeder protection, then again with the transformer protection. Why it is repeated in my video? Because it must be clear. I have told you the cities are connected. It seems that it is connected in parallel, but it is not connected in parallel. I have told you repeatedly. Why? Because the direction of the current of the two cities is reverse. One is incoming and another is outgoing in both the cities. So polarity will be reversed. polarity will be reversed in the secondary. So through the relay it is connected in series. It is connected in series and another end is earth. After joining the two other end, that we have earth it. Why it is called? It is called what? One is system protection, another is equipment protection. It is system protection. Live wire earthing is called system protection. System earthing, not protection, sorry, system earthing. System earthing and equipment earthing. Now the question is, if I earth it, will it not be short circuited? I have told you already, short circuit means to complete a circuit without load. Here simply our traction transformer one end secondary is also earth, but the circuit is open. When the loco will come, it will act as load, then it will come to the track to the A. Then only the circuit will complete. But if there is no loco and then the secondary of the transformer is just like open circuit, but if you it will complete the circuit with a loco, then there will be a load, so it will not be a short circuit. The earthing is giving the return path here neutral, just like neutral. So clear idea about the short circuit. Short circuit means to complete a circuit without load or without minimum resistance, so that huge current will flow, because I is equal to V by R. If your R or impedance is low, huge current will flow. So this is the short circuit. So for our system, all the transformer secondary one end is earth. City secondary one end is earth. In potential transformer also, one end of the secondary is earth and primary one end is earth. These are all system earthing. How it is helping this system earthing? If any leakage in the insulation, it will complete the circuit and trip the circuit breaker. The current will vary and trip the circuit breaker. So these are all for safety protection. Insulation failure and everything, or dead earth fall near the transformer, all will be arrested by the two current transformer. But its restriction is CT to CT, primary CT to transformer, then transformer to secondary CT. This is the system. So I think you have got some idea about the electrical system. We are using two types of isolators, two types of switches. One is load switch and one is no load switch. Load switch is that which can be closed or open during current to no current, even fault current also. But during fault current, this load switch will open automatically if it is a circuit breaker and assisted with relays. But some other load switch also in our system, that is interrupter, it will not open automatically. CB will open and make the circuit dead, then you can operate it again. So CB is associated with relays. And it is during any fault tripping automatically. But some switches are physically, you can see the circuit is closed or open, that is isolator. It is no load switch. That means when the circuit is incomplete, break, at that time you can make or break it. So to energize a transformer, first you have to close the no load switches, then this circuit breaker and everything you can close. During circuit breaker close condition, you don't close the isolator switch or open the isolator switch, huge spark will occur and its blade will melt. So it is no load switch. It is opening and closing in air. No insulating media to extinguish the spark. But in circuit breaker we are using extinguishing media like SF6 gas, In the past days it was insulating oil, and nowadays vacuum circuit breaker is also we are using. So it can extinguish the spark, the arc. It can extinguish the arc. So it can be closed in no load to full load, even in short circuit, and even can be open also. Can be opened also. So this system includes what is the gist? Gist is electricity can flow only when its circuit is complete. Any electrical circuit must be equipped with isolating system, because electricity is harmful for our body. If no isolating system is there, then if any accident occurs, it will remain continue. It will continue. So isolating system, immediately you isolate it. Just like you run, you switch off the main switch. Switch off the main switch. If anybody will get shock or use fire extinguisher anything, then you have to open the isolator or circuit breaker. Where it is power circuit breaker will be opened. And again we able to know that with the CT and PT we are reducing the current and voltage for the use of the for use in the panel board, where operator can operate it. Operator can operate it within safe limit. Otherwise, the huge amount of current and voltage you directly cannot operate. So 110 volt battery system is used, and you are using auxiliary transformer to step down 25 kV to 110 volt, and using in the battery charger. Through this, the DC is through rectifier is generated, and we are charging the batteries and also using for the relay protection as a DC supply. Power transformer is can withstand our traction load is frequently changing. So we are designed the protection system like that. We have taken it can withstand 200% load even for 5 minutes. So we have designed it in various way, like overloading it. The IDMP setting is somewhere is 190%, somewhere is it is 180%. Somewhere 180% means in HV side and 180% in LV side. And then time multiplier setting we are setting, then stage 1, stage 2, stage 3, that is 140%, 167, 180%, and time setting is also given, the guideline from the RDSO. And in the secondary side also the same thing. Then post overload. What is post overload? After tipping in overload, again how for time again you can close it, because continuous overload is not good for power transformer. So again you can not operate it has given the time time setting. In summer it is HB side it is 70 second, and in LV side it is 60 second. In LV side it is 60 second. And in the primary side we have used two cities. One is load city, another is earth city. In the secondary also, though secondary is earth, but our return current is coming to the track to the earth leg. The earth is connected with the buried rail and a earthing mesh below the Taxan substation, and it is connected with that thing. So return current is coming to that end to the power transformer. So two cities are used. One is line city and another is earth city. So these are all MB2 cities. Both are connected in series, and it is helping not only the instantaneous but IDMT as well as restricted earth fault. IDMT to permit the overload for a particular time. Slowly it will, if the time will reach that threshold, then the CB will trip. The CB will trip. And ammeter is also there. When the current is 2 to 7.27 in the CT secondary, it will be reduced by 5 by 400. The ammeter will get that current, but it will show 2 to 7. That is calibration. But system is calibrated in such a way that during the huge power circuit load current, though it has reduced through the CT, it will show that reflects that power circuit current, but actually it is taking less current. Friends, today up to this. Good night. Any question you can ask me. Okay, and next I will discuss about the 20 to 25 kV setting, because all the system is switched to 20 to 25 kV system. The basic system is same. The same relay is used for 20 to 25 kV, but in the 20 to 25 kV, the voltage will become 55 kV instead of 27 kV. Instead of 20, so you can change accordingly. Okay, and you can calculate in this way by 27 kV. Another thing is shunt capacitor bank. There are two capacitor banks. One is series capacitor bank, switching capacitor bank, and another is shunt capacitor bank. Shunt capacitor bank, it is a fixed thing, fixed capacitors, but our traction load is always varying. In some section, throughout the 2 or 3 trains is going, so their shunt capacitor bank during no load condition it will lead, and again power factor will increase. Power factor will decrease. Sorry, power factor will low power factor. If it is unity, maximum is up to unity, but again if it will go to lead, again the power factor will reduce. Again the power factor will reduce. So another thing is power factor correction. In the later slides I will discuss all these things. Why I am discussing it repeatedly? Because the traction substation is the main thing of railway electrical engineering. Not only railway but everywhere, a substation is really a, what I can say, clear idea about the electrical arrangement. You see, the CDs are connected in series, but it seems that it is connected in parallel. Then you go in the depth, then you will see that the direction of the CT current is reversing from one bit to another. So it is in series circuit. So this type of basic thing you will clear from a substation. So I am repeatedly discussing this thing. Your idea will be clear. Okay, thanks man, good night.